Today we're going to take a look at how to solve quadratic equations. The first way that we're going to look is simply solving by undoing, which is how you solve most equations that you come across, especially linear ones. What solve by undoing means is simply get x alone. First example, we're going to add 1 to both sides. Divide both sides by 9. And then take the square root of each piece. Now in this case, because I put the square root symbol on there and it wasn't there to begin with, we do need that plus or minus sign. If we put negative 1/3 into the equation, once we square it, it becomes positive 1/9, multiplied by the 9 becomes 1, and 1 minus 1 is 0. So that is a solution, just like the positive 1/3 is. For example B, we cannot solve by undoing because we have both an x squared and an x term. So we'll set this equal to 0 to see if we can factor. Typically, I would just subtract 4 from both sides. However, in this case, my x squared term is negative, and I like my x squared term to be positive. So I'm going to add 5x squared to both sides, subtract 12x from both sides, and move those over with the positive 4. Next, we're going to set up our t-chart for the AC method, thinking about what multiplies to a positive 20 and adds to a negative 12. Those numbers would be a negative 2 and a negative 10. I will use those to split up that middle term. And then factor by grouping. So my first two terms have a common factor of x. My second two terms, in order to get the signs to match, I want to factor out a negative 2. Factoring one more time, pulling out that 5x minus 2 as a common factor, leaving me with x minus 2 equals 0. Next, I'm going to use what's called the zero product property. I have two pieces being multiplied together to equal 0. The only way to multiply and get 0 is if one piece or the other equals 0. Solving my first equation by adding 2 to both sides and dividing by 5, we get x equals 2/5. Second equation, adding 2 to both sides. The next way we're going to look at for solving quadratic equations is completing the square. For part A, notice that this does not factor. There are no numbers that multiply to 5 and add to a negative 8. For completing the square, it's helpful to start by isolating your two terms with an x, so I'm going to subtract 5 from both sides. Other than completing the square, when you solve quadratic equations, you do want to get it equal to 0, so this is the only one where you don't set it equal to 0. Next, we're going to force this to be a perfect square trinomial so that we can factor it as a binomial squared. The way you do that is by remembering that pattern when we factored perfect square trinomials. We take the coefficient of x and cut it in half, square it, and add it to both sides. So 4 squared is 16. I'll expand that on my right-hand side. And now thinking about on the left-hand side, what happens is what multiplies to 16 and adds to negative 8 would be a negative 4 and a negative 4. So we can rewrite that as a binomial squared. On the right-hand side, combining our like terms, we get 11. Now we can solve by undoing. In this case, we're going to take the square root of both sides first because that's on the outside of my parentheses. Remember, when you put a square root on the equation, you also need a plus or minus sign. And then we're going to add 4 to both sides. So x equals 4 plus or minus the square root of 11. Next, on example B, we have a coefficient in front of our x squared term. First thing we want to do is divide that out. It's easier to complete the square if our leading coefficient is 1. Next, we're going to cut that 6 in half, square it, and add it to both sides. 3 squared is 9. And then we have a perfect square trinomial, what multiplies to 9 and adds to 6, positive 3 and positive 3. Taking the square root of both sides, put that plus or minus sign on because you put the square root on there. And finally subtracting 3 from both sides. Finally, we're looking at the quadratic formula. If you haven't already, check out the video I posted of my boys singing the quadratic formula for you. It's to the tune of Pop Goes the Weasel. Eli kind of started out by talking, so you might not recognize that tune right away. And hopefully that will help you memorize the quadratic formula when you put it to music. Trust me, you do not want to hear me sing it. For the quadratic formula, we need to identify our a, b, and c. A is the coefficient of our x squared term, b is the coefficient of our x term, and c is the constant. So our quadratic formula is x equals the opposite of b. The song goes negative b because it has a better flow, but in this case our b is negative, so we make it opposite. It becomes positive, plus or minus the square root of b squared. I always drop the negative sign on the b if there is one, because once you square it, it becomes positive, and the negative sign might cause an error in your work. So just get rid of it. Minus 4 times a times c. All over, make sure that fraction bar goes all the way in front of that first term and not just under the square root. 2 times a. Next, we're going to simplify what's under the radical. We are not going to give decimal approximations because you guys know how to simplify radicals. 64 minus 24 is 40. All over 2 times 3 is 6. 40 does simplify. It has a perfect square factor of 4. So I'm going to take the square root of 4, which is 2, and there was a 10 left over. This is the part where it gets a little tricky because you have to simplify the 6, 8, and 2 all together with what they all three have in common, and they all have a factor of 2. So I'm going to divide each of those pieces by 2. You do not divide what's under the radical. These are being multiplied, so you can't divide each of them. You only divide the term as a whole, which would be the 2 on the outside. You've got 2 U-try problems on this one.